Any of them, you choose.
No, I'm not choosing.
33.
33, I heard. Now, if we do choose one that happens to look like stuff on the quiz, I might mention that, but I think I mentioned last time what the stuff on the quiz would probably look like.
I wasn't here.
I think I said that.
You want to
so-
repeat that?
No.
Let's get our, I'm gonna get my phone up. I didn't write that down. That was
33.
Your phone's on. But you like, you called that before you started?
Yes.
Oh yeah, because I saw the light go on.
Can you give me a few minutes?
It's divided by 1/2, right? Or multiplied by 1/2.
Is this not the equation?
Did you not record last class?
Parentheses 1 minus
I did, it's one middle.
times 1/2.
Is this the equation?
33.
I don't even.
Only because
I didn't get
I didn't get
Didn't he tell us this last time and then we looked it up?
I don't-
26.
Oh, the minimum sample size.
I don't remember getting it, you know.
Did I not?
I got it.
But,
I got it first block.
but the
Last
video
class I
is
remember
on
six.
Google.
Yeah, the 6.8 times.
33.
33.
Says use a given confidence interval to find the estimated margin of error, then find the sample mean.
C. This is
Good choice. Did you hear that, Riley? I'm sure there were several people who didn't hear it. Wait, what?
Oh, and then that one, yeah. Sorry, we also have to put that number in. Oh, is that it?
Is that the right, is that, did I write it right?
Yeah.
So, they want us to find X bar, and they want us to find E from this interval. Most of the stuff that we've been doing, we were trying to find the interval from this.
I mean,
I'm trying to help you out to make you have a better day. See how nice I am? So to do this, we talked about this last time. From this interval, we're saying that and I don't know what the confidence, I didn't read the whole problem, what the confidence level was, but with, let's say 90% confidence, we can say that the mu, the mean of the population, is going to fall within this interval. But this time what they want to know is what was the mean of our sample and what was the margin of error that we were dealing with. To find the mean of the sample, we add those two together and divide by 2. Somebody help me out.
28.15.
Does everybody agree with that?
Yep.
Now, before I go any farther, is that the mean or the margin of error? Mean. What should be true about that mean as far as our interval goes here? It should be right in the middle here. Is 28.15 between those two?
Yeah.
Yeah, so then that makes sense. To find the margin of error,
Subtract.
you subtract. Instead of adding those two together, you subtract and divide by 2. Please make sure, again, when you're doing this on your calculator, you do the top part first, hit equals, then do the divided by. Because I guarantee some of you on the test, quiz, whatever it is that we're doing, some of you are going to come up with an answer like 43 on this next one. And that's what you did wrong, is you didn't punch it into your calculator right. What's this one come out to be? 1.95?
Yeah.
Does that make sense for that margin of error? The way you can sort of look at it, our mean was about 28. 1.95, that's about 2. Does this end go up about 2 from 28? Does it go down about 2 from 28 on this end? Yeah, it makes sense. That's your margin of error. So those are your 2 answers. Next question. 38. .38 says constructing confidence intervals. You're given sample, this one they want a 90% and a 95%. I don't think on the quiz, I don't think I did both 90 and 95. I think I just did one, but this is another good one to keep in mind how to do. And we'll probably do this one using our calculator. Let's see here. In 36 randomly selected seawater samples. So what's that tell us? N is what? 36. That's our number in our sample. So let's write that down. Probably don't need it. The mean sodium chloride concentration was 23. So that's the mean. So that's our X bar. 23, I think I said, right? Per cubic meter. And the standard deviation was 6.7. So that's our S, that's 6.7. And they wanted us to make a confidence interval, I lost my page, for 90% and for 95%. Before I do that, what should be true as the 90% interval relates to the 95%? Which one's going to be wider and which one's going to be narrower? 90 is going to be wider. Everybody agree with that?
No, 95.
95 is wider. The higher percentage you get, the wider you want it. Because if we wanted to say 100%, right now, I could do a 100% interval, and I could do something like this. Negative 10,000 to 3 million. Are we 100% sure that our mu is going to fall in that range? Yeah. It's not even possible that it falls anywhere else. So it's just about every number that could possibly be in this. So that's why we don't ever do 100%. So 95 gets wider. That way we're more sure that it falls in that range. Now to do these, and again, might be pretty important here, we're probably going to use our calculator. Is that the way we want to do it, or do we want to do it longhand?
No, do it.
Calculator? On your calculator, what are the steps that you hit? Stat. Test. Z interval. Or does it say Z in, or it's got interval? Some of them say something. All right, so then once we have that, then I think most of them pop up a different screen, right? Once you get to Z interval, it pops up a different screen, is that correct? And then the first line says stat or data or something, doesn't it?
Yeah.
And we want to highlight stat. What's the next line say?
Once you're in stats, you just start plugging in. So you plug in like standard deviation.
Standard deviation. What is our sigma this time?
6.7.
But that's S.
But it doesn't the same thing.
Oh, so for that, we still
Yeah.
just do S, right? So 6.7. What's the next one say?
X bar,
X bar,
which is 23.
23.
And then it has the N, which is 36.
N, which is 36.
And then our confidence level.
Confidence level, that's the C, right?
Yes, which is 90 or 95.
What is it? And I wrote my 95 out here. I'll write it out there. For 90, we're going to do 90 first, right? So you put in 0.90 or 0.9. You hit enter, and it should give you the interval. What's it say?
21.163 and 24.837.
837. Is that right?
Is it on stat?
Did you
Is
hit
it on
enter
data or
twice?
is it on stat?
Did you go down to calculate?
Oh, yeah. Oh, I pressed enter twice.
Oh, no,
Oh, yeah.
It just gets
Press enter
rid of it.
twice to like,
I didn't know that.
put it away, it just
Yeah.
comes up with.
Oh, it comes up with something else?
Yeah.
It comes up that 1382.
1382, which is, that's probably something else that we would use, which I don't want to get into and try to figure it out right now to confuse everything. But hit enter twice normally goes from this and then takes you to something else, and
I don't know how to do it on my calculator.
Riley doesn't know how to do it on his calculator.
Go to Z interval.
Riley, go up and grab one of my calculators, and I'll. Can you figure it out?
I mean, yeah, but it didn't come up with the.
Oh, you got that cat.
You're on sample Z test. You're not.
I don't think there's.
There should be a Z interval.
Never had a cat.
Is it?
Because he doesn't
Yeah,
have cats.
a Z test is something else. So that's what we have here. When we do the 95%, without actually doing it, could somebody give me a guess what's going to be true about it?
It's gonna be wider.
So it could be something like 20 over here and 25 over here, or something like that maybe. All right, might not be that wide, but I don't know for sure, but it's going to be wider than this one. So let's punch all this stuff into your calculator. Once you go to stat, the test, Z interval, all that stuff. Once you get to all that, what's the only thing you have to do this again?
Just change it to like
Change that to 0.95. What's it give you?
20.811. And then.
Hold on now. 24. Is that smaller than that?
Yeah.
Oh, okay.
Yeah, last time went down.
Okay, so it went down a little bit.
And then 25.81. It's 189.
Does everybody agree with that? Yep. Again, how would we find the mean if we were given this? Add those two together and divide by, and what should it give us?
23.
It should give us 23. What if we subtracted these two and divided by 2? What should it give us?
6.7.
Should, or no, sorry. It should give us the
Okay, I was like, never
E.
mind what you're
My
talking
fault.
about.
I did that last time too, didn't I?
Yeah.
Just listen. It should give us the margin of error. Other questions?
Is that all we went over last month?
Yeah, that's basically it.
Pretty much, Let's do 53,
Got
that's a
it.
3 part.
Right, the sample size. You said 53?
Yeah, it's an ABC question, but it's not ABC sigma over it.
No.
53 says cholesterol contents of cheese. A cheese processing company wants to estimate the mean cholesterol content of all 1 ounce servings of cheese. The estimate must be within 5 milligrams of the population mean.
Which number is this?
53. If they want everything to be within 5 milligrams, what number are they giving us?
0.5.
They're giving, or 0.5, they're giving us the margin of error. That's what they want. When they say that, that's what they're giving you, is that margin of error. So we know that E is 0.5. Let's see what else they tell us here. Determine the minimum required sample size to construct a 95% confidence interval for the population mean. Assume the population standard deviation is 2.8 milligrams. So they're saying sigma is 2.8. How they know that sigma is 2.8, again, I have no idea. So I just heard somebody saying that formula a minute ago. To find how many samples we need to take, or how many we need in our sample size, it's N equals, what was it again?
The Z.
ZC right? The critical value times what? Standard deviation sigma over E. That's all squared. First thing, before we find the ZC, we'll do that here in a second. We know sigma is 2.8, so I'm just going to write that in there, 2.8. We know that the margin of error is what this time? 0.5, we write that in. Now we got to find the critical value, and we find the critical value by looking on this packet. And what was it? Because I just closed my book. What percent or what was our C? 90? 90%. So we look at 90%, 1.645. Is that right? Put that in there. We're going to square that. Somebody multiply these two, then divide by that and square it for us. Tell me what answer you come out with.
I don't know if that's correct, but 84.86.
What are we going to do to that? So we need about how many in each sample? 85. I don't know if it's right either, but it sounds good. What number, what letter B say? Because I'm not reading my book because I've lost
A
pages.
using a 99% confidence.
So now instead of 90%, now we want what? 99%. So everything's going to be the same.
Is that for 95 or?
I thought they told me it was 90. For part A was 90?
For 53?
Yeah.
53
It is 95.
Oh.
No wonder my
That's why I
answer's
was,
different.
yeah, I was like, what did I do wrong?
That's right. So let's go back.
Oh, yeah.
For 95%, 1.96. Do that for us. What are we going to do with that? So about 121 we do in our sample size. This next one's 99, so we look up 99 on here, it's, oh, you stupid thing. 2.575. So, till I get my thing fixed here, won't be recording. Oh, I had that right here. Yeah, it's still recording, I just can't see it. 2.575 times 2.8 divided by our margin of error, which was 0.5. All that squared. Somebody do all that for us. 207, and you're going to round it up to 208. So we need about 208. Does that make sense? If we want to be more confident, we put more in our sample.
Yeah.
What's part C say?
Which one had a larger sample size?
Which one had a larger sample size? Which one? 99%. The more precise, not precise, I shouldn't say that.
More confident.
Smack Brian.
Don't do that.
I found out what.
Phone away.
Man, that was sneak years.
So the higher your confidence, 99%, the bigger your sample size should be. Other questions?
I think we're good.
Quiz.
Sure.
Let's do it.
You say happy birthday to Michael?
Happy
birthday
to
I was scared to make it.
Happy birthday to you. Happy birthday, dear Michael. Happy birthday to you.
Yay. I'm gonna smoke cigarettes.
Good.
Now you're legal, Michael.
Yeah, don't wear it like that.
go straight here.
I'm already telling Dusty.
Yeah, they just jacked up to 21 here a couple months ago.
Dusty walked in, he goes, where you at? Where you at? You're 18 now.
Okay. You get an 18
This is it?
birthday spanking.
I didn't even check the homework.
You?
Or did you?
There ain't even somewhere to put your name.
But I needed to check my old homework that I didn't do.
Are we allowed to use our notes?
Yep.
Yeah.
Use your notes, use your homework, just can't use your neighbor.
Is it?
No, I'm gonna pass out more since.
Yeah, don't
this,
worry like
this
that,
hit
dude.
3 times.
Well,
That's
that's just a question. You could have said yes. Didn't have to be all mean about it.
I did say yes the other time.
I didn't hear them.
All right. That's because you weren't.
I'm not listening to them. 'Cause that's wasting breath. Like I'm wasting breath right now.
Could've been done already.
When you get finished, you can bring it to me. See some notes on the board, you can start copying them as soon as I get my projector reset. Shouldn't take you more than a couple minutes. First one, you should have 2 answers. Make sure I know which answer is which. And don't just say, well, you should have known. Make sure you show me. This one's X bar, this one B. Confidence intervals for means, same thing we were doing, except before we were doing large samples, which meant n had to be larger than what? 30 or bigger, all right? Now we're going to do small samples. So if you were doing a confidence interval for a sample that was 10, that's what this is going to do. And this is, it's not really harder, but some of the stuff with the charts and stuff, you'll have to use your charts on some of this, all right? So the confidence intervals for small samples. Now what is going to make this harder is when we get to the test over this chapter, Leah's going to have to remember how to do it for small samples, how to do it for big samples. If you get the two confused, then you're going to get lost. First thing, instead of a Z distribution, this is called a, sorry, let me get my pen out here. Yeah, you stupid thing. It's called a T distribution. So on stuff like your calculator, instead of a Z interval, what do you think you're going to be doing? T interval. I think we talked a little about that last time, didn't we? That it was right there close to. Sorry, that wasn't me. That formula right there, that tells you how to find each T. We're really not going to use it.
We don't need to write it down,
Yeah, it's up to you. I'm saying we're really not going to use it. We may use it here and there. So probably it's, I mean, if Sean's arm falls off, I hear him over there making all these funny sounds like he's dying or something. If his arm falls off because he wrote down those 5 letters, then I'm going to have Riley come over there and Riley will hold your arm up to your shoulder for the rest of the class so you can continue to write.
Thank you, Riley.
Yeah, no problem.
It's like, why don't you say that in the beginning?
Because I wanted you to write it down so that you have it. Critical values, the critical values now instead of Z sub C, they're going to be T sub C. Try to say that 10 times fast, Phoenix.
I didn't hear what you said, no.
That sort of thing.
Should be, this is next week. Yeah.
I'm trying to be.
You might honor next week.
I'm going to be the person you hate the most if you don't put that phone away and quit trying to hide it.
It's like calculator.
Quit trying to hide it in your calculator thing like I'm an idiot or something.
I wasn't even getting honest.
I know, it just, you can't help it. It's just like you start having withdrawals and it wasn't touching your hand for 5 seconds.
And that's what you're wrong.
It kind of fits right in there.
It did, it slid right.
I'm gonna take Sean's next, cause he's over there on his a bunch and he usually quits
It's only-
about the time I start to walk that way, so I
It
don't
only-
say a
it
whole lot.
only fall out.
Don't do that. Properties of a T distribution. A T distribution is bell shaped, and again, I don't know that I would write all these down. You might want to, just sort of write it down, but paraphrase each thing. This is what makes something a T distribution. Still bell shaped, still normal, still symmetric. It's a family of curves. Each is determined by degrees of freedom. What's degrees of freedom again? You're probably never going to see me write it out again. DF. And DF is n minus 1. So what this is saying is, you're going to find the degrees of freedom for each one, and each one is a different curve. That first formula up there would tell you how to draw that curve. So what's going to happen, and I'm going to draw this out to the side while you're writing. We have our normal curve, but n has to be more than 30 for that to work. What a t-distribution looks like is this. Maybe something like that. Notice it's up above the x-axis, and it's real thin and stuff. And this says it's a family of curves because the different ends you get, if you do 10, 11, 12, 13, 14, 15 as your sample size, then it starts to do this. Oops, can't draw very well. It starts to get closer and closer to that normal curve. And when we get to about 29, guess what it sort of almost looks like? It looks like just about like the normal curve. All right, because then we're almost to a large sample size. The degrees of freedom, you're just going to take whatever they tell you n is in your sample size. If it's 10, then your degrees of freedom, we did this on other stuff earlier this year, it's just 10 minus 1, which is 9. Then we're going to have to use that 9 to look up stuff on the chart. So it's a family of curves, and again, all that means is that it's a different curve for every n. And for every n, as you get higher and higher for your n, it gets closer and closer to that normal curve. Which one's more precise? Our z distributions that we were doing or the t distributions?
Probably Z.
Z. The z is just because we have a bigger sample size. All right? So we use this. Why do you think we even use t distributions then?
When you got.
All right, so if I was going to do a sample of you guys, can I ever use a z distribution? No, there's not 30 people in here. All right, so it wouldn't work as a z, so I'd have to use a t. Now I said that z distributions are more precise. Which one do you think gets used more in the real world? The t. Shouldn't.
So how often are you going to do less than 30 people?
I think there's a lot of
It shouldn't get used more. Why do you think it gets used more? It's easier. Remember I said something about the election between Trump and Clinton? Guess what they did?
Summed it up to less than 30.
Right. They just stood outside certain places and did something easy and, you know, recorded for like 15 people or something. Now, if you do that, then your number's going to be way off. And you're saying, oh, yeah, we think it's going to be right here. Yeah, that's true. You think it's going to be there. And then it could end up way over here or way over here. Total area under the curve, still 100%. Mean, median, and mode, still all equal to 0 on the curve. As the degrees of freedom increases, is what I was talking about. It approaches the normal distribution. Just to show you, I did all this over here. Notice if your DF is 2, you're way up here, is way off. Didn't look like the normal. If DF is 5, it's there. If DF is, I don't know what I made that one. Oh, that was just the normal. Let's see, yeah, sorry. So that's all the stuff I just said on the other screen, except for telling you that hopefully you still knew that under the curve was gonna be 100%. That's for any normal curve. And then the mean, median, and mode, just to refresh your memory, mean, median, and mode always are the same if we're normal. I might throw a few of those on the next test. So I'm going to tell you that the mean is 72. And that's all I'm going to say now. I'm going to say, find the mode.
Are you gonna say that's normal?
Yeah.
Okay.
Yeah, I guess I should say that. So.
We just have 72 find mode.
Yeah, then you couldn't do that. If the distribution is normal, what's the mode? Hopefully Phoenix was listening to that one right there.
I was listening to it relate back to this.
Sean, did you hear Sean? He said under his breath that we couldn't hear him way over here. You didn't hear him?
I don't think he was.
He thinks, I don't know why, he thinks I'm like 100 years old or something, or something, way across the room over
You
there.
were just all like, you gonna put somebody on the test?
He was listening, see?
Yeah, shut your mouth, Sean.
What on
Stay
a
quiet,
test?
boy.
What on the test?
What are you gonna put on the test? These mean, median, and modes, and they're all gonna be the same.
Close enough.
They have to be perfect, I said I didn't hear one of this.
He's getting mad at us now.
I know.
Man, we can take A-Specs.
I still love you, Phoenix.
Leave it alone.
Find the critical value TC for a 95% confidence interval when the sample size is 15. This is where you need to get your chart out. So we got these charts. For the Z confidence intervals, we use this. Can't use that now. We need the T intervals. So I bet if you flip back through, at some point you'll see one that says a T distribution. Anybody find it?
Yeah.
Like the 5th page, but Gage is probably like a lot of you. He got frustrated going back about 3 pages in, so he started going from the back forward. That's the way my sons are. I say, all right, figure this out. What's this going to be? And they get to about where they need to be, and then they think, well, this isn't working, so then they go to the other end and start backwards, and then it takes twice as long. Everybody find it? So on this, first thing you need to find, our N is 15, but we need our DF. What is DF this time then? 14. All right? Just 15 minus 1. And all you're going to do on here you see, you got to be careful. We're going to use this whole chart. Sorry, I had to stop and think for a second. We're going to use this whole chart, but you see where it says one-tailed and two-tailed and all that? We're not doing that right now. All we're doing is level of confidence C. So we're just using the top part. So you go over to 95, and you go down to where your DF is 14. And I'm not going to be able to read that because it's in the dark thing.
2.145.
So our critical value is 2.145. It's that simple.
See, subtract 1 from 6.
Right. Because that's how you find your degrees of freedom. So it's just 15 minus 1. Remember, degrees of freedom, going back to the start of the year, when we do degrees of freedom, if every seat in here was going to be filled up, and I put Riley in a seat, so he's there. Now nobody else can have that seat. So now Gage's degrees of freedom, where he could set, is one less than that. Once I put you down, then the degrees of freedom, one less than that, and so on, so on, so on. Gotta show all my motion here. Okay, now look, 14, I guess I could have done this and I could have read it. Go over to that. Again, we're not using this stuff right now. We will, but not for this. So we're saying that this critical value, that's where it'd be. What's the percentage gonna be inside this blue part? 95%. What percent's out here? 2.5%, and on the other tail? 2.5, so on, so on, so on. To write a confidence interval, we're gonna do the same thing. This you need to write down. We're probably gonna write our confidence intervals in the parentheses instead of using the alligator mouse, like we did with the confidence intervals on the last one. To find the margin of error, that's the formula this time. Basically the same formula as it was the other time, except this time it uses TC instead of ZC. And Sean, there's no way, shape, or form this time that I'm going to say, after all this, you didn't really need to write all that down. These you need. Unless I'm lying again.
I mean, we kind of already have it written down.
So X bar, the mean minus the margin of error, is your low limit. The mean plus your margin of error is your high limit, just like stuff that we just did on the quiz. And you guys already know that there is a way to do that on your calculator. Instead of Z interval, it says T interval, and we're going to get to that here in a second. Now, do I hope this goes back to everything that you ever do in any math class? It's great for a computer or calculator or something to be able to do it for you. That's spectacular. It's also great that if that computer or calculator is giving you the wrong answer, you know it's wrong. Because if you don't know it's wrong, you're just going to look stupid. That's all there is to it. All right? And I probably told you guys the story at some point. I had somebody sitting in here in geometry class that just drove me nuts. Very smart young man. His name was Steve. Also. Very smart young man, was going to be a pilot. Always telling me how he did not need geometry to become a pilot. And I kept telling him, you're right, you may not ever use any of this geometry being a pilot. But all of the stuff that goes into the computers uses triangulation to figure out GPS, where you're located at and stuff. And you need to know if that computer's telling you the wrong thing. And he goes, well, I need to know that. The computer's going to tell. Why do I? And it was that same year I sort of got lucky. Well, I shouldn't say that, because it was a very, very bad thing that happened. But it was good for me, because then I could explain to him. Somebody over in Europe crashed an airplane full of passengers into the side of a mountain, and they all died. And the reason that happened was because the computer was messing up. The pilot, who probably knew that the computer was messing up, passed out. I don't know why, he was sick or something, and he passed out. So the co-pilot had to take over. Well, the co-pilot was a trainee. And so all he did, because he was nervous, I'm sure, was he watched all those gauges and everything on the plane, and okay, we're all right, bam, they hit the mountain. Because the computer was screwing up and wasn't telling them the right position. Now, if he'd known that the computer was messing up, maybe those people would still be alive. But he didn't know all that stuff. So, moral of the story is, I told the young man that was in here, I said, please make sure that if you're ever flying for a passenger air service, to make sure that every time you come on the PA and you say, I will be your pilot, this is John Smith, so that way if I'm ever on there, I know to get my butt off. The probability that the confidence interval contains mu is C. Again, to interpret it, and I wouldn't write that down, we have it down, you know this already. To interpret it, we're going to say with a 95% confidence, or with 95% confidence, we can say that mu is between this number and that number. Nothing really hard about it. I'm not going to have you, I'm not going to have you write all this down. Are we going to find X bar this way? Usually not. We're either going to stick the list into our calculator and find it that way, or add them all up and find it that way. You don't need to know the whole big formula. So probably not going to use that to find X bar and S. Identify the degrees of freedom. Hopefully all of you remember that to find the degrees of freedom, you just take n minus 1. That's not too difficult. To find E, we just wrote down this formula, margin of error. Just do that. Then we're going to add and subtract to find the interval. Again, we're probably going to write it that way instead of using the alligator mouse. Nothing really hard about it. Do we want to do these out longhand, or do you guys think you can handle that? You can handle it, so let's just use the calculators. So let's see if we can figure it out on the calculator. Grab your calculator. Where do I use my calculator at? Yep. Yes.
Like an hour ago?
Yes, sorry. Yeah.
She just emailed me and was like, what happened to her mind?
You might tell her, and don't say it's from me, just say, you know what, Ebersole doesn't really believe in counseling, so all he believes in is math. So if we go to, I think it's stat, test, somewhere on there is our T interval.
Yeah.
Go down to T interval, then it pops up that same screen like we had on the other ones, right? Oh, the bad thing this time is what? We don't have all this stuff, do we? We don't have X bar, we don't have standard deviation. Oh, that's because we're just looking for the critical value.
We're just using the chart.
My fault. Here we're just using the chart. I should read what I wrote. So this time we're just using the chart. What's DF? 11. Somebody help me out and look up. 99, DF 11. Say it again. 3.106. Do the next one. Let's do these real quick. I don't know why I didn't put these before this.
1.721.
I know what happened. 1.721?
No, you gotta subtract 1.
1.725.
DF equals
Oh.
is n minus 1.
So it's 20 this time, right? 20 and,
1.725.
is that right?
Yeah.
2.4%.
Next one, 2.447. Everybody agree with that? So those are our critical values.
You about 50% confident?
Now to find the margin of error, we use that E. Can you guys do these, or do we want to go? Let's do one. I think we just got done doing this, didn't we? The 0.99 and the 12, was that what the first one was over here? So TC is 3.106. So to do this, it's gonna be 3.106 times, what goes on top?
2.4.
Standard deviation, what goes on bottom? Square root of n, which is 12. Somebody do all that for us. Remember, I multiply these two first, hit equals, then divided by the square root of 12. That way your calculator doesn't tell you it's an error.
2.15.
2.15, anybody else get that? Yeah. All these basically gonna be the same thing, alright? So that's how you find E. Now construct a confidence interval. This is where we're gonna use our calculator. Sorry, I thought this was next. You know what happened is, this is Barnes's kids were in here, or well, one of the kids was in here this morning, and she was doing this with my pen on the board, messing with me. And I wasn't really paying a whole lot of attention, and I said, don't mess up my PowerPoints, and she was moving the slides around, I didn't catch it. So we go to stat, test, Z interval. Do we have enough now? Do we have everything we need?
Yeah, T interval.
Or T interval, not Z interval. I went to the wrong one.
Oh, I went to the wrong one too.
So make sure you don't do that. Don't be stupid like me. Thank you.
Yeah.
Make sure we're going to stats. Again, data is if we're putting in a list.
Head to the loading bar for that.
Yeah.
Stats is, let's see, the first one here, the X bar is 14.2. S is 2.4. N this time
I've never
is
seen a calculator have to load before.
12. Yeah, it weights. What else do we need here? What's our confidence level? 99. Calculate. At least it doesn't have the little circle going around in the middle.
Yeah.
That's
Then you can
annoying.
play Snake.
That's annoying. What did it come out to be?
4.048.
Anybody else get that?
Yeah. 16.352.
352? Just to make sure our answer makes sense, where should this be?
No.
Is that between those two?
I guess so.
Yeah, it looks like it's pretty close. Try the other one real quick. Tell me what you get on it. Does anybody have any idea why it takes it a little longer? Instead of using the Z table, it's using that T table, and that's a little
It's got
harder.
flip to the back of the packet.
It's, right, it's got to go in and find it.
Then it pulls a gauge.
Goes the wrong way at first, and then it comes back to it.
8.366.
8.366?
And 365.
Is it a 6?
And then
They rounded.
9.434.
Does everybody agree with those two?
Yes.
Just again, to check your answer, make sure here, 8.9, would that fall in the middle there somewhere? Is this one about 1.7 below that? Oh, no, that's wrong. Why do I keep doing that? Because that'd have to be the margin of error, right? Not the S. It's Mackenzie. She keeps telling me that. Messing me up. You randomly select 16 coffee shops and measure the temperature of coffee sold at each. The sample mean temperature is 162 degrees. This problem was big when I put this PowerPoint together, because at that point there was like 10 lawsuits going on with McDonald's getting sued because
Wasn't that lady's fault though?
yeah, it was all their faults, and I think that's what they ended up, right, with the hot coffee. So McDonald's was getting sued by all these people because the people were spilling the coffee on themselves and burning themselves. And then they wanted millions and millions of dollars. So this was a big thing then. The sample mean temperature is 162 degrees with a sample standard deviation of 10 degrees. Find the 95% confidence interval for the mean. So this is our C. This is our X bar. This is our S. Assume the temperatures are approximately normally distributed, as Ben told us earlier. I think it was Ben, wasn't it? Or no, it was Michael. Michael said, no, you gotta tell us that it's normal, and so that's what they did there. Same idea here. We want to construct the confidence interval, so we go to the T interval. I don't know, can you go back and go into that? So stat, test, T interval, X bar is 162, S is 10, 16, thank you, and our confidence level. Please make sure, you gotta make sure you put in, it seems like some of the calculators, you can put in just 95 and it'll understand it. And some of them you can put in, you have to put in 0.95. I don't know which calculator is which, so you can try it and see. What'd it tell you?
156.67.
And the high side?
167.33.
So again, what we're saying with that, if we were going to interpret this, is if Phoenix owns all these shops, he owns some coffee shop making millions and millions of dollars, he buys Starbucks, he owns it, and he wants to make sure, he's saying with 95% confidence, I can say that the mean temperature of all the coffees that we send out falls within that range. Why might that be important to know? I'm sure there's some range where 2nd degree burns, 3rd degree burns, and stuff like that, right? Probably, as long as you're within this range, I would think a normal shower, I don't know, you could look it up. How many degrees do you think a normal shower is?
I'd say enough to get some steam going.
How much?
I'm guessing
130? Somewhere around there maybe? So if your normal shower is 130, you think 167, what is it, 105 really? That seems low.
Yeah.
I thought 130 was pretty close.
Well, there's a lot more people who shower.
Yeah, they might shower in the cold, I guess.
Most people don't even.
So if you're finding just the average, that's, so 167, do you think that really should cause you real bad
105
burns?
120 degrees is the highest they go.
What is it?
120 degrees is the highest they can go.
A shower?
That's like the max safe, like that's safe.
Sounds like a challenge.
I think there's no way that the temperature.
I don't know, I know our, on my water softener, it's got or my water heater, it's got 3 settings. And most of them just say low, medium, and high if you get inside of it and mess around with it. And I know mine has actual numbers on it, and I'm pretty sure my setting is like one I set on is like 135 or something is the water temperature. So, I don't know. I'd have to go home and look
I
at
don't
it.
really want boiling water on my back.
That's true.
I heard.
So I just did this out, doing it longhand, finding E and finding the TC and all that stuff, and found the right endpoint and the left endpoint, doing that, and that looks about the same as what we came out with. And then that's what our interval would look like. To do a normal or a T distribution, when we get to the test, you're going to have to ask yourself, is N greater than or equal to 30? If it is, then which one do you use? Use normal or T? The Z, the normal. So if yes, you go and you use the Z stuff that we did last time. If no, Then you go to the T stuff, or then you ask yourself, is it normally distributed? Well, it's probably going to be normal, or otherwise I wouldn't give you the problem, right? If it's not normal, then we can't do either one. Well, I shouldn't say that, because we could approximate it like we did last chapter and do all that stuff. But we haven't covered that yet in here, as far as that. So use the T. Is sigma known? If yes, then we can use the Z. If no, then we have to use the T. So, that's the other thing I should say. My fault. N is greater than or equal to 30, we use the Z. Also, if we know sigma, we can also use the Z, no matter what the sample size is. All right? But, and the book will tell you sometimes, and you hear me every time we do a problem where they tell you sigma, I say, how in the world did they know sigma? If they know that, then why are we doing all this? Because then you should know what the mean of the population is. Because you can't find sigma unless you can find the mean of the population, or you know the mean of the population. I'm skipping that. This is just asking which one are we using. This is doing the same thing, except again, I didn't use the calculator, I used all this other stuff to find it. Confidence interval. We wrote that down, right? Same thing. Again, just to make sure, if they give you a list of numbers, you can put it in one of your lists, and then you do data instead of stats, and it'll do all the stuff for you. You won't have to, if you do the data, it won't ask you for all this stuff because they'll already have it in there. That's the assignment, page 323, 1 through 16, all, and 17 through 31, the odd.